In this video, we're going to learn about the addition rule for probability. This is going to be the first of the rules that will allow us to calculate probabilities without having to write out the sample space and the specific events and count how many of each there are. We can just use these rules here to calculate probabilities. Before we can get into the addition rule, though, we need to talk about what are called disjoint events. So two events, I can spell again. So two events are disjoint if it is impossible. Remember, impossible means probability of 0% for both events to happen at the same time. Now, in terms of math notation, let's say you have your E and F here. Remember, these are listing of different outcomes. When you put this upside down U symbol, it means the intersection. So what outcomes are in common with both E and F? And then we'd have the symbol for the empty set, meaning that there is nothing in common between them. Very quick example of this, if you're rolling a dice, E is roll an even number, and F is rolling an odd number, and those are disjoint. It is not possible to roll a single dice and get a number that is both even and odd. So that's it. Those are disjoint events. Another way of saying this is that if you take the probability and you say, I want E and F to both happen, it means both happening at the same time, this probability is 0. That's, again, meaning impossible. Now, once we know what disjoint events are, if E and F are disjoint events, then the probability of E or F happening is just equal to the probability of E plus the probability of F. So let's go back to the rolling a dice situation. And instead of doing even and odd here, let's say the event E is either rolling a 1 or a 5, and the event F is rolling a 2. Now, these two events are disjoint. There is nothing that is in common between my event E and my event F. I can also calculate the probability of E is, I have 2 things in E over 6 things total, so it's 1/3 or 2/6. And the probability of F, well, there's 1 thing out of 6 total, so just really 1/6 here. And so if I wanted to say, if I roll a dice, what's the chance that I either get a 1 or a 5, or I get a 2? This is the probability of E or F here. Because they're disjoint, we can just add them up, and we would have 1/3 plus 1/6, and if you actually add them up, you get 1/2. Feel free to convert that to a percentage if you want, but a lot of times we'll leave things as fractions if we can. So that means the probability of getting either a 1, 5, or 2 is 50%, or half. Now the only problem is that this addition rule only works when you have disjoint events. And sometimes you don't have disjoint events. In fact, very often you have events that are not disjoint. However, the general addition rule is going to work whether they are disjoint or not. This is going to say the probability of E or F is equal to the probability of E plus the probability of F, like we already had, minus the probability of both E and F happening at the same time. Now notice that if they had actually been disjoint, then this last term would have been 0 and it would be gone from the equation. That's why the first addition rule looks very similar to the second one, because if you just drop off the term that is 0, you get the first rule. Now, the general addition rule is something that we will definitely use more often than the other addition rule, because events in general are not going to be disjoint. Quite often they're going to be not disjoint. But this formula here will always work no matter what events we have. So let's go to E being getting an even number and F being getting a number that is bigger than 1. Sorry. We get anything bigger than 1. So 2, 3, 4, 5, and 6. We know the probability of E, there are 3 things out of 6. Probability of F, there are 5 things out of 6. And so if I want to find what's the probability of either getting even or getting something that is bigger than 1, if I use the general addition rule, and I have to because these are not disjoint, right? Because they both have 2 and 4 and 6 in common. So the probability of E is 3 out of 6. The probability of F is 5 out of 6. And then I need to see when do they both happen. So what things are in common between both of them? That is 2, 4, and 6. So that's 3 things out of 6 that are in common. And if you go ahead and combine this out here, you are going to get 5, 6. Note that if you had not subtracted that off, you would have gotten 8, 6. And 8, 6 is the number bigger than 1. And that can't possibly be a probability. So that's another thing to keep in the back of your mind. When you're doing these probability calculations, if you get an answer that is bigger than 1, you messed up somewhere. Because you can't have a probability bigger than 1. Okay, so we get this here, and we get a probability of 5, 6. And that's what we have for the probability of either getting an even number or getting something bigger than 1. And you can use this to find probabilities of all other situations as well. Just use the general addition rule. There's 2 other things I want to mention here. One is this idea of complements. So the complement of an event is everything other than the event. So in the case where E was rolling an even number, E complement is everything other than rolling an even, so that'd be 1, 3, and 5. And we can use a kind of a version of the general addition rule to get what's called the complement rule. And this is just going to tell us that the probability of the complement is 1 minus the probability of the event itself. And this is something we are actually going to use over and over and over again, probably even more than the general addition rule, because it turns out a lot of the time you're trying to find some complicated probability and you have this really complicated event and you just can't figure out how to find the probability of it. But if you say, wait a second, let me take the complement, let's take everything other than the complicated event, and quite often the complement is going to be simpler. And you are going to be able to use that to take your problem, convert it into a complement problem. Like if you were to solve for this here, for probability of E, it's the same formula, just solve for a different part here. And so if you can then convert your problem to a complement, find the probability of the complement, if it's easier, then do 1 minus it, you'll get back to the probability of the event you were looking for. So we're going to see this in future videos, this exact thing where we're going to take a problem that the way it's written is hard, but if we find the complement, it becomes easier, and then we can use this rule to get back to the original probability. The last thing I want to mention really quickly here is I've used the word disjoint this whole time, and that's the word I usually prefer, but there is another term that is used both in your book and other people will use it out there, and it means the exact same thing. So I'll mention it right now, and that's called mutually exclusive. So anywhere you see mutually exclusive, it means the same thing as disjoint. I don't care which one of them you use. I will pretty much always stick with disjoint because that's the one I'm more used to, but it's important that you know this other term is out there in case you come across it.